physical chemistry, and these are the little course we talk about. The little course we talk about types of rate of reactions. We have initial rate of reactions, average rate of reactions, and the last one is instantaneous rate of reactions. Then we talk about rate law and calculations. We talk about reaction order and its calculations. We talk about rate integral of the rate law. We talk about the first order, second order, and half-life respectively. Let's talk about types of rate of reactions. We have three types of rate of reactions, which includes the average rate. When we talk about the average rate, we have initial rate. Initial rate of a chemical reaction is defined as the time taken, or is defined as the periods in which before the two reactants collide with each other before a product is formed. For instance, if we have HCl plus sodium hydroxide, give us sodium chloride plus what? Plus water. So initial rate is just a rate before the chemical reaction occurs, or is the rate before each of the reactant, or each of the elements, or each of the atoms of these reactant molecules collide with each other. It refers as what? Initial rate. Let's talk about what? The average rate. When we say average rate of chemical reaction is defined as the change in concentration of the reactant or change in concentration of the product with time taken. For instance, we can have the average rate can be changed in concentration of reactants or products over time taken. That's what we refer as average rate. The change in concentration of the reactants or concentration of the product over time taken. Why instantaneous rate? The instantaneous rate of chemical reaction is defined as the particular moment or the particular instant during the course of chemical reactions. It's a particular moment or particular instant during the course of the chemical reactions. That's the three types of rate of reaction we have: the average rate, the initial rate, the average rate, and instantaneous rate. And that leads us to rate law. What do we understand by rate law? When we talk about rate law is basically defined, or it can be determined. Rate law, it can be determined experimentally. It can be determined experimentally by summing the relationship of the rate of reaction, rate constant, and concentration of each of the reactants raised by the power. This is the definition of rate law. Rate law is defined as the relationship between the rate of the reactions, rate constant, and concentration of each of the reactants raised by the power. That is the definitions of rate law. Relationship between rate of reactions, rate constant, as well as concentration of each of the reactants raised by the power. And mathematically, rate law can be written if we have a situation where we have the HCl plus sodium hydroxide to give sodium chloride plus water. If you want to write rate law for this, we can do this. We have the K, or you said is proportional to, we have HCl by the power X, then we have sodium hydroxide by the power Y. Remove the proportionality and we put K. So which means rate law is equals to K bracket HCl X, and we have a sodium hydroxide Y. This is all about the rate law. For instance, if we ask you to write the rate law, this is how to write the rate law. This one is order of reaction with respect to this. This one is order of reaction with respect to this. Let's assume we have this equation where we have here is 2, here is 2. For you to write the rate law for that, we can say rate law is equals to K bracket HCl 2 and what? Sodium hydroxide 2. So this one is what? Second order with respect to HCl, and this one is second order with respect to HCl. If you want to get the overall order is equals to this plus this, meaning 2 plus 2 is equals to what? 4. So order of the reaction, overall order of the reaction is equals to 4 by multiplying the power we have in each respectively. So having known that, we now specifically progress to reactions order. When we talk about reaction order, what do we understand by reaction order? Reaction order with respect to each of the reactants is directly or is defined as the power of each of the concentration of the reactant raised by the rate expression. I will repeat myself. Rate, excuse me, we have reaction order. When we say reaction order with respect to reactant is defined as the power raised by the concentration of each of the reactants raised by the rate expression. So this is the definition of rate order. The rate order or reaction order is defined as, with respect to reactant, is defined as the power of the concentration of each of the reactant rise to the rate expression, respectively. And we have the first order, we have the second order, we have the third order, irrespective of the question being given to us. And we can also use it to solve various questions that is being given to us specifically. How are we going to solve equations under reaction order? For instance, if we have an equation like this, we have experiment, we have initial, we have experiment, we have N2, which is the M, this is the moles, we have HM, we have initial. This is a question that you might experience in exams. So here is experiment 1, experiment 2 of the 3. The first one is 5.0 times 10 to the power minus 3. Here is 1 per dm cube. This is 10.0 times 10 to the power minus 3. This is 10.0 times 10 to the power minus 3. And here is 2.0 times 10 to the power minus 3. This one is 2.0 times 10 to the power minus 3. And this one is 4.0 times 10 to the power minus 3. This one is 1.3 times 10 to the power minus 3. This one is 5.0 times 10 to the power minus 3, and this one is 10.0 times 10 to the power minus 3. So now the question will be asked is, number 1, find the order of the reaction with respect to NO. Question 2, find the order of reaction with respect to hydrogen. Question 3, they will ask you to find the rate law. And lastly, they will ask you to find the rate constant, which is the K. Also, they can ask you to calculate overall order. And to solve a question like this is very simple. We have equation 1, we have equation 2, we have equation 3. To solve for order of what? Reaction with respect to NO2. What you are going to do, the principle behind it is you pick any of the equation that the two of the equation that you pick for NO2 must be the same, must be different. While NO2 must be the same so that they can eliminate each other. So if you want to do that, you think of equation 1 and equation 2. If you observe equation 1 and you divide the highest by the lowest, the highest is 10. So you divide equation 2 by equation 1. Just say divide, okay, just say pick equation 2 and what? Equation 1. And divide equation 2 by equation 1. So to do that, it's going to be, you write the same thing, rate is equals to K, forget about your K, rate is proportional to NO2 or NO times H2. That's how you do it. Divided by the same thing. Rate is proportional to NO and what? H2. Now this is equation 2. You divide equation 2 by equation 1. So we have what? Initial. Right? Initial. What is our initial? Our initial for equation 2 is 5.0 times 10 to the power minus 3 divided by initial of 1.3 times 10 to the power minus 3 is equals to. What is this? You can make this to be x. So you put the value of this for equation 2. The value of this for equation 2 is what? 10.0 times 10 to the power minus 3 divided by equation 1, which is what? 5.0 times 10 to the power minus 3. That's for what? For this NO2. That's what we want to do here. NO2. And for H, which is the same thing, equation 2.0 times 10 to the power minus 3 over 2.0 times 10 to the power minus 3. All. Here is y. Here is y, here is y respectively. So if you observe, this will cancel this. Automatically, this is equals to 0. As gone. So now if you observe here, if we have x here, if this goes here is 2. This here is also what? 2. Automatically, you have what now? 2 is equals to 2x. You make x under the formula, divide this by 2, divide by what? 2. 2 cancel 2. X is equals to 2 goes here 1. So it's what? The first order with respect to NO. That's we solve question 1. You go to question 2. How do you solve question 2? You find solve order of reaction with respect to hydrogen. Solve order of reaction with respect to what? Hydrogen. So what I'm going to do, if you observe, these are hydrogen. You will now pick where you have hydrogen. This different. This and this is different, right? This and this is the same. Automatically you pick, divide equation 3 by equation 2. So divide equation 3 by equation 2. So what are we going to have? We have our initial rate of equation 3 divided by initial rate of equation 2 is equals to, let's do it now. To do that now, we have initial rate of equation 3. What is the initial rate of equation 3? We have 10.0 times 10 to the power minus 3 all over equation 2. 5.0 times 10 to the power minus 3 is equals to initial rate of this NO initial rate for equation 3 is what? 10. We have what? 10.0 times 10 to the power minus 3 divided by 10.0 times 10 to the power minus 3 all in what? X times, what is this value? We have H plus, which is same thing as equation 3 is what? 4.0 times 10 to the power minus 3. Then here will be equation 2. 2.0 times 10 to the power minus 3. Here is y. Automatically this is equals to 0 because this will cancel this to give 1. Automatically here 1, here 2, here 1, here 2. Automatically when you have this, you have what? 2, right? Is equals to, here we have 2x. So divide both sides by 2, divide by what? 2. 2 cancel 2. X is equals to 2. Now if you divide this by this divided by this, I think here 1, here 2. We have the same thing, divide by 2. We have our y, because x has already become 0. Our y is equals to 1, which is what? First order with respect to hydrogen. I think I've solved question 1, I've solved equation 2. Let's solve the last equation here, which is overall order. Overall order is your x plus y and your